Aloha my kako. Hey my wonderful students. I just wanted to go over some concepts and review some concepts from 10.2, which was graphing quadratic equations. This is a supplement to all you've learned in class and also in Mr. Mike's videos. And I hope it can help some of you understand this concept better. Okay, but before we begin, I want to start with a joke. What happens if you cover a tennis racket with ice cream? You get soft serve. All right, thank you. I'll be here all week. Guys, I wanted to help you out and go over this question with you as another example. And hopefully, like I said, it can give you a worked example so it makes the concepts a little easier for you. Okay, so we're going to graph y equals negative 2x squared minus 8x plus 1. The first thing we have to realize is this. The graph of any quadratic equation is a parabola, okay? Now, this parabola, this isn't this parabola, but I'm just sketching it. Any parabola will have an axis of symmetry, okay? As given by x equals some number. The graph of the equation of a vertical line is x equals some number, all right? And that will at least tell us where the parabola is located. So that is really important because if we're just given an equation and a blank graph, it can be quite daunting. It's like, okay, where does this graph even exist? Where do we even start? And that is the key. We're trying to find this axis of symmetry, which is given by, for any quadratic equation, here we go, guys. It is given by x is equal to negative b over 2a. Now we can write that any number of ways, but this is the axis of symmetry, okay? Meaning this negative can float either up on the top or right in the middle. I'm going to choose to write it on top. And I guess that's how I normally do it. You wouldn't see that in the textbook, but this is how one can think of it. Okay, so we're going to find the axis of symmetry first because we want to know where on the xy plane this graph exists. So we would go, okay, x is equal to, for our particular quadratic equation, this is our a, negative 2. This is our b, negative 8. And this is our c value, which doesn't come into play in this problem, but it is positive 1. So I'm going to go x is equal to negative b. That would be the opposite of b. That's how we can think about it. So the opposite of negative 8, because negative 8 is actually our b. Okay, over 2 times my a value, which is negative 2. Notice I can simplify this quite a bit. The numerator will be 8. I'm just going to take my time. The bottom is negative 4. This is x. This simplifies to x is equal to negative 2. And I'm going to write that as a summary. X is equal to negative 2 is my axis of symmetry, my AOS. Okay? Now, why is that important? Why would I take my time to write this summary statement? Because that is a big deal. I now know this graph is symmetric. The graph of this parabola is symmetric to this vertical line, x is equal to negative 2. Now, what I don't know is how high or low it is, which brings us to our next step. Okay, and our next step is to find the vertex. Now, the key to finding the vertex is, first of all, understanding the vertex is a point on the xy plane, and it has an x and it has a y value. Okay, it has an x and it has a y. Now, the x value, here's the kicker, if we can understand this x value, which is the axis of symmetry, is also the x value of the vertex. That totally makes sense because our parabola will be symmetric around x is equal to negative 2, and that is the x value, negative 2, of our parabola. Okay, so I'm going to plug in negative 2 for our x, and all I need to do is find our y. So how do I do that? I'm just going to plug in negative 2, of course, in for x, into the function itself. Okay, that's the only thing we can do. So we're going to plug in negative 2 into there. I'm going to skip a few steps. I'm going to plug in negative 2 into here and square it and plug it into here as well. Okay, so I've got negative 2 squared, which is actually positive 4. Negative times negative is positive. So that will be y equals negative 8. And I'll plug in a negative 2 here. That'll be plus 16. And we have plus 1 to round out the calculation. And I have here y equals 9. And that is the value of my vertex. Those are the coordinates. That's the y value of the vertex. So I can go in and put my point there. Okay, negative 2, comma 9. Now, after I find the vertex, I'm almost there because my parabola either goes up or down. In this case, it opens downward because the a value is negative. The key, the next step here is to complete a table. Okay, now here is me making a table. I already have 1 point. That is the vertex. I'm going to put it smack dab in the middle. Now from -2, okay, x is -2, I'm just going to pick some x values around it, namely -3 and -1. Okay, you can see that's around it. And by symmetry, these y values will be the same. And I just need one more because having 5 points does give us a good picture of the parabola. I was at -2. This is the x equals -2. This is the axis of symmetry. Instead of plugging -3 and -1, I'll also go -4 and 0. X equals -4 and x equals 0 to round it out. And these will be the same. Okay? Now, at this point, it doesn't really matter. It will be a matter of preference whether you're going to plug in a -3 into this function to get a y value or -1 to plug it into that same function to get a y value. The y values will be the same, so you're just basically looking what should be easier. I'm thinking plugging in -1 should be easier. So here's my work for that. Y equals -2, -1 squared. -1 squared is +1, so that will be the first term, -2. And then I'll have +8 because it's -8 times -1. I'm plugging in x equals -1, by the way. And then I'll have a +1 to round out the calculation, and this will be y equals 7. Okay? So I have here, this is 7 and this is 7. I'm almost done. It'll be over quick. So here's the thing. I can plug in a 0 or a -4. Obviously, the better choice is rhymes with Nero, 0, correct. Okay? I'm going to plug in a 0 here, here, and you can automatically see the y will be 1. Okay? So if I plug in x equals 0, my y will be 1 because all the first term, quadratic term, and the second term, the linear term, will drop to 0. So this is my y value of 1. This is my y value of 1, and I am done. I'm going to go ahead and graph all these points, and I'm going to graph -4. I'll graph these two first, I guess. Okay, just so we get a picture of our parabola. -3, 7. That will be up here. I'll have -1, 7. 1, 2, 3, 4, 5, 6, 7. Yep. Nice mirror image. And I just need 2 more points, which will be -4, 1. 1, 2, 3, 4, 1. Bing, bang, boom. And 0, 1. Bing, bang, boom. And there you see our nice parabola emerging. We'll put in a good sketch. And I hope that was super helpful. And I'm going to recap everything we did. Okay. And there it is. That is a sketch of our parabola. First, we have this graph. The first thing we need to do is find the axis of symmetry. The axis of symmetry is given by x equal -b over 2a. That is for any quadratic equation. The opposite of b, in our case, is 8. Okay, because b is -8. The opposite, we can think of this negative as the opposite of b. So we're going to have 8 over 2 times a, 2 times -2, because a is -2, and that got us this. And we simplified the -2. X is equal to -2 is the key understanding. That is the axis of symmetry. Okay, that gave us this idea. This also provides the x-axis of the vertex, and that's a big key idea, okay, to be able to make that connection. So I then plug in a -2 into our function, okay, and do a calculation. I will get 9, and that is right here, -2, 9. From here, I need to build a table, so I pick x values around it, -1 and -3. And I'm also going to pick 0 and -4. Now, we don't have to calculate all of these because of the symmetry, so I picked one of them, and you can rewind to see which ones I picked. And I've got this graph, and I'm going to zoom out. I will compare it to Desmos. Okay, Desmos is a good tool you can use. Go to desmos.com. You plug in the same equation, and this graph is indeed the same as this graph. We've got -2, -9 as the vertex, and it does go through 0, 1, which we knew it did. Okay, that's also right here. And we see the mirror image point right here, which is also reflected right there. Okay, that's -4, 1. Which also appears on our table here. So guys, I hope that's super helpful. Please let me know if you have any questions. Mahalo, have a great weekend. Bye-bye.